is an asteroid. It is made up of the same things planets are made up of: rock, metal, and other elements, except they're way too small to be planets. In fact, they're so small, the combined mass of all the asteroids in the asteroid belt is less than our moon. There are a few theories about how dinosaurs died out. This is one of them. 65 million years ago in a place called Chicxulub, Mexico, an asteroid hit and left a huge crater. This crater was more than 180 kilometers wide. The explosion, likely caused by an object about 10 kilometers across, would have released as much energy as 10 trillion tons of TNT. Well-known impact craters often have tektites associated with them, as well as shocked quartz and tiny glass spherules. Tektites are formed when rocks are quickly melted and splashed out of impact sites in the form of big pieces of molten glass, then cooled when spinning through the air. Walter Alvarez and his colleagues found that rocks laid down precisely at the KT boundary contain massive amounts of metal iridium. The dating is precise and the iridium layer has been identified in more than 100 places around the Earth. On Earth, iridium is rare. It's much rarer than gold. The same high ratio of iridium is found in meteorites. The Alvarez group therefore suggested that iridium was scattered worldwide from a cloud of debris that formed as an asteroid struck. What would happen if an asteroid hit Earth? When people hear about an impact, riots would happen all over the globe and it would be chaos. 75% of the Earth's surface are oceans, so it'd be pretty likely for an asteroid to hit an ocean. Water will be pushed aside to form a tsunami. The steam blast from the water at the crater site rushing back over the hot crater floor will also produce tsunamis following the initial impact tsunami, and crustal shifting as a result from the initial impact would produce more tsunamis. The material ejected from the impact through the hole in the atmosphere will re-enter all over the globe and heat up from the friction with the atmosphere. The chunks of material will be hot enough to produce infrared light. The heat from the glowing material will set fires all around the globe. Global fires will put about 7 times 10 tons of soot into the air. The heat from the shockwave of the entering asteroid and reprocessing of the air close to the impact produces nitric and nitrous acids over the next few months to 1 year. These are horrible acids. They will destroy plants, kill upper ocean organisms, let loose harmful elements like mercury and thallium. The dust from the air and the soot from the fires will block the sun for several months. There will be a dramatic decrease of sunlight, making plant photosynthesis stop and the food chain collapse, as well as making the temperature cold. After the cooling, increased temperature follows, due to the large increase in the greenhouse effect. It becomes too hot for comfort.
Here is an easy 3-step method on how to avoid asteroid impacts. 1. Detect. Use high-tech technology to find the threatening asteroid and its exact location. 2. Analyze. Find out important things about the asteroid. 3. Exterminate. Get rid of it. There are a few theories about how we could do this.
1. Perform a standoff nuclear explosion. This is a nuclear explosion when the bomb itself doesn't touch the asteroid, but the impact would send it flying in another direction, without breaking it into more life-threatening pieces. 2. Heat up the asteroid until it produces a jet of vapor which will push the asteroid out of the way. The asteroid can be moved out of the way and Earth won't suffer from any side effects. But this means preparation. It can't be a last-minute discovery. Plus, there's a slight chance of breaking the asteroid into pieces that could possibly harm us. Although the chances of Earth being hit by an asteroid are very slim, it may have happened before and it can happen again. It could be at any time, so it's better if we are prepared for this situation.